Okay, welcome back. In this lesson, we're going to be talking about our tidal current tables. So we've already covered our tide tables. Now we're going to be talking about our tidal current. And luckily, these work very similar to how our tide tables worked. Okay, we have a table 1 with our reference stations or our primary stations. We have table 2 with our tidal differences, or I like to call our secondary stations. And then we have our index to the stations in the back of the book. And just like before, I usually work in the reverse order: index, then table 2, and then table 1. And then just like our tide tables, we also have to consider anything that is working in daylight savings time. The tables do not account for that. So if you're solving for a time, then you need to add an hour to that for if it says anything about DST or daylight savings time in the problem. Okay, so here's our table 1, where, like I said, we have our primary stations. It gives us this Delaware Bay entrance. The flood directions 342 degrees true, ebb directions 152 degrees true, and then it breaks it down just like before, the month, the days, and then let's take a look a little bit closer at one of these days. So now we have a column. Looking at the first here, we have a column for slack water. That's when the water is not moving. And then we have a column for maximum. That's when it's moving at its fastest. And we can see the maximum, it has a speed associated to it. So if we're looking at the first here, it's 0029. It was at its maximum flood, so 1.4 knots. Between 0029 and 0331, it hit slack at 0331. So it slowed down and hit slack at 0331. So again, we're back in our 24-hour time. Now between 0331 and 620, it started to pick up speed, and at 0620 it was at its maximum ebb of 1.2 knots. And so that's how we apply this. So we'll be looking for and showing you how to figure out the time of slack water, in which case there's a time adjustment or time difference that we add to the slack water. We'll also be solving for the time of the maximum flood or ebb. That's the F stands for flood, the E stands for ebb. And then we also may be required to figure out the velocity of the maximum flood or ebb. So we're going to see how we do that when we get to table 2 with all of our differences. So again, there's our slack water column. There's our maximum column. Okay, so here's table 2. Looks very similar to the table 2 in our tide tables. Again, the far left column we use has the, let's pull this up a little bit bigger. The number there, we get that from the index. Again, the first place we go to is the index. We find the location, we get the number. We then get, it shows us the place, the meter depth, the position, all good information, but not necessarily what we need to solve the problem. What we do need to solve the problem are these piece of information here. We need the time differences, and we need the speed ratio. So this is where there's a little bit of difference here. So we see under time differences, there's a min before the flood, a flood, min before the ebb, and then an ebb. So the min before the flood and the min before the ebb, those are the time adjustments that you will apply to the slack water. And then the time differences for flood or ebb are the time differences that you apply for the maximum. Okay. So again, they are plus and minus hours and minutes. And again, always be careful adding or subtracting time. And then if we were trying to calculate the velocity of a current, then we'll take the speed ratio for the flood or the ebb, and we will multiply it against the speed that we saw back in table 1. Okay, so if we're solving for velocity, then we're going to go to the speed ratio, get the speed ratio for the flood or the ebb, and apply it to the speed back in table 1. And we can see here under that one spot, we see it says on Delaware Bay entrance, page 72. So that is telling us what primary station page we're going to go to for all of these different locations. Again, you're going to see this when I work out one of these problems for you real time. You'll see exactly how we apply all this information. So this was just a one side of the world of our tidal current table. So a little bit more on the differences for those. We explained what those were. And again, back to our index. That's where we go to find our table 2 secondary station information. So we start with the index. We go to table 2. we're going to grab whatever differences we need, and then we're going to go to table 1, and we're going to apply those differences for whichever day and whichever time we are looking for. So again, 1/3 of the world of our tidal current station.